for the next 5 minutes or so, okay?
Mhm.
Gotcha. Okay. So the question that you shared with me was, if I remember correctly, it's basically a piece of, what do you call it? A block or whatever on an inclined slope. And what we do know are the starting and end positions of the slope, right? I think it's like 8 comma 2.
Mhm.
So based on this information and the fact that I'm drawing this as a right triangle, this will let us know theta. And I'm writing this theta not as a variable, but as something we could literally calculate if we went through and pulled out our basic trig knowledge and punched it into a calculator, right?
Mhm.
So I didn't actually calculate it myself, but let's just pretend this is like a legitimate number, like 35 degrees. And I wouldn't do this if I was explaining to a more experienced student, but I know that in the intro phases, students really like it when they have concrete numbers to deal with rather than variables.
Mhm.
So, okay. The idea here is that they're asking us to find a force and splitting that up into components. Parallel and perpendicular. So I'm just going to write this as capital F and
Mhm.
drawing it kind of roughly right here. This is the force that's perpendicular to the slope, and this is the force that's parallel to the slope.
Mhm.
Yeah.
Mhm.
So the trick behind these kinds of questions, how do I put it? The trick behind these kind of questions is to figure out which one of these angles is theta. Do you know that off the top of your head? Have you seen these done enough of these problems so far to be able to instantly tell?
No, actually,
Okay,
no.
that's perfectly fine. I just wanted to know uh, what phase you're in. At a certain point of doing physics, uh, my professor liked to joke that there's a deep theorem in physics that angles that look alike are alike, and you can usually eyeball it past a certain point. But I'll go through the explanation. So again, I'm just writing theta is equal to just some random number I came up with, 35.
Mhm.
You'd have to actually calculate it for yourself. But the trick here, the first trick, is to draw a line straight down.
Mhm.
Excuse me. Draw the line straight down and draw another line like this, parallel. So this, I'm going to make a little notch right here. So this is parallel to this, and it's parallel to this,
Mhm.
right? So with this in mind, because they're literally the same, uh, do you believe that this angle right here is also theta? Because this line is parallel to this line, and they're both intersected with this line down here. This is called like traversal angles or something.
Mhm.
Do you believe that this angle is theta?
Does it mean it's related to the 35 or?
I mean, it's literally the exact same angle. So I'm saying that this angle right here is exactly the same as this angle right here.
Mhm. I do see like the
Yeah.
pattern.
Do you just remember from like maybe high school geometry how if you had a two parallel lines like this and this angle was theta, then this angle would also be theta?
Oh, I have some memory now that you draw it out and everything.
Right. You draw it out isolated. This is exactly the situation over here. You see that?
Mhm.
Right. Exactly. So okay. So we've established that this angle is theta, and keep in mind that because this is the ground, and by definition I've drawn this as a perpendicular. So if this entire angle is 90 degrees, then this angle right here is 90 minus theta. With me so far?
Yes.
Okay. So I'm going to draw this kind of funny, but I'm just extending this line long enough to make it match up with this one over here. Um, so, excuse me. How do I want to talk about this next? So, I'm reminding you that this line over here is parallel to this one over here, and
Mhm.
this line over here is well, I've drawn it to be perpendicular, right? So, which is to
Mhm.
say that this angle right here is 90 degrees, and
Mhm.
this thing here is a triangle. You see that?
Yeah.
So if this is 90 minus theta, and this is 90 degrees, what angle is this?
Is it like the 30, 60, 90 chart?
Not a 30, 60, 90 in particular, but just if this is 90 minus theta, and this is 90, what angle must this be?
Okay, yeah, let me calculate.
Sure. Maybe I'll draw it off to the side just to make it a little bit less messy. but this is 90. This is 90 minus theta. What is this?
Mhm.
Take your time.
55?
Yeah, sure. Yeah, you got it. You got it with the explicit value of 35. But yeah, it's 55 in this problem, or more generally, it's equal to. Wait, hold on. My mistake. This one's 55.
Oh.
This one's 55, right? So what's this one? What's this one?
Wait, how does the bottom one become 55? I was kind of confused.
This one right here,
Yeah.
90 minus theta. Well, we justified why this angle is 90 minus theta, right?
Hmm.
So 90 minus theta, I'm just plugging in 90 minus 35 is equal to 55, and that's this angle right here.
Hmm.
So this angle right here, I'll tell you, let's call it angle x for a second.
Hmm.
And we know that x plus 90 plus 90 minus theta is equal to 180, right? And what we see here is this is 180 together. So these two 90s cross out with 180. So it turns out that x is just theta,
Oh, okay.
right? So now this is just angle theta.
Hmm.
Okay. Well, now we keep going. Now I'm going to, sorry, my diagram's a little bit messy, but if this right here is theta and this whole thing is 90 degrees, what is this angle?
Sorry, which angle are you pointing to?
Yeah, sorry, it's getting a little bit messy. Let me draw this out over here. So I'm saying that this is theta, and I'm asking about this one right here, with this entire thing being 90. Do you see that?
Is it the one near parallel force? A component?
Yeah, it's the angle I'm talking about right now is the angle between force perpendicular uh and just the force itself.
Oh, okay. Is that um
Remember, this one we said for this particular problem, let's just let it be equal to 35 as a guess, as a ballpark estimate.
mhm.
So this one right here ought to just be 90 minus 35. 90
Mhm.
minus theta. Okay.
Okay.
And that should be everything you need, right?
Hmm.
At this point, yeah, my diagrams have gotten really, really messy. But at this point, we've actually finally figured out um, one of the angles of this triangle over here, right? This is the triangle between F perpendicular and F parallel. And of course, by definition, we know that this one's a right angle. We figured out what this angle right here is. This one is 90 minus theta. So of course, this angle over here must just be theta.
Hmm.
And at this point, we know the hypotenuse of the triangle, which is just force itself. So at this point, this should all be high school trigonometry. Do you see that?
Yes. Now that you like labeled everything.
Yes. I think I could definitely work on my handwriting and the clarity of my diagrams, but I hope this process was reasonably informative.
Yeah, definitely. Because I remember the one I did in class. It was like a much more simpler diagram. So this was like kind of new to me.
Yeah, there probably is a simpler way to see this. Like the thing about geometry problems is that probably, there's probably always some smoother way to do it. Um, in fact, I was actually thinking about a simpler explanation just earlier, and what I came up with was, so this is the ground, right?
Hmm.
And if you just draw another just imaginary line that's parallel to the ground, maybe like a ceiling or something, then this angle is theta, means that this angle is theta. This is like alternate interior angles or something. Do you remember that
Hmm.
from geometry?
Yes.
Yeah. So if this angle right here is theta, what do we got? Okay, we got, so maybe I should label this with two lines to indicate that it's different from the slope, which is just one line. Okay,
Hmm.
but so the slope and F parallel are, well, parallel by definition, by construction. So the idea here is that, and also the force, which is perfectly horizontal, uh, is also parallel to this thing over here, to the ground and to the imaginary thing.
Mhm.
So you can kind of see that an angle formed between the thing with 2 notches and a thing with 1 notch ought to be exactly the same angle as over here, the line between 2 notches and 1 notch. You see that? You see how this angle has to be the same thing as this one over here?
Mhm.
Yeah, that might be a faster way to see it. It's also a bit more hand wavy, but I think it should be clear enough.
Mhm.
But at this point, I'm hoping that you can maybe take care of the rest
Yeah.
by trigonometry. And
Mhm.
again, let me stress that I just chose the angle 35 just off the top of my head. You got to figure out what the actual angle formed by these things are. But I, hopefully trust you to do that.
Okay,
What
yeah.
is that?
I think.
Distance of horizontal is 6 and a rise of 2. So just whatever, I think you did take the arctan of 1/3.
Mhm.
But yeah, I'm going to end recording right there. Gosh. Yeah,
Yeah,
good
thank
problem.
you.